right, exponential growth, chapter 11, section 3. So, an exponential growth function is another curve that will increase more and more each time or decrease more and more each time. A formula is right here, and that means that the final amount equals the original amount times 1 plus the rate as a decimal to the time, which is typically in years. So if we do a sample problem here, an employee is promised a 3% raise if she starts at $40,000. In 10 years, what would her salary be? That would be initial amount, which is $40,000, and the percent increase, 3%, is 0.03. So that's 1 plus 0.03. You could write that as 1.03 right away. We were doing this a little bit in the last section. And then to the 10, because 10 years. So 40,000 times 1.03 to the 10th. And in the calculator, that will give you $53,756.66. All right, if interest is compounded, that means that you have another letter in your equation, which is n, and you would make it that much more often. So let's invest 1,000 at 12%. 12% is 0.12, so 1 plus 0.12. And probably the easiest is if you have a graphing calculator to type this equation in under y equals. So, to the x. So if I put 1.12 to the 0, anything to the 0 power is 1, so 0 would give 1,000. And then 1,000 times 1.12 is 1,120. So your total would be 2,220. Compounded semi-annually means you're going to compound it twice a year. You're going to compound it at half a year and then again at a year. The rate is still 12% though, so that's the total rate. So in all actuality, you would be increasing 6% each time to get a total of 12%. So if you multiply this by 1.06, you're going to get 1,060. And if you multiply that by 1.06 again, you're going to get that. Let's not worry about the totals because this next one's even a little more weird, compounded monthly. So we start at 1,000, and again, that 12% has to last the entire year is 12%. So if we think about our 12th one, we would have 2012.2. So if it's compounding 12% every single month, we would increase it 1% each month. But the easier way to do this is to work with the formula. Y equals P times 1 plus R over N to the NT. So the principal being $1,000, compounding at 12%, 12 times a year for 1 year. So you would have to change these numbers into the decimal to properly plug the time in, because time is in years, and this 12 is really 1 year. So if I plug the 1 in there for 1 year, I get the 2012.2, and then you can go back and get all the other ones. Probably the easiest way to do that since that formula exists. And it looks like this, where n is the number of times it's compounded. So you can see that n appears here and here. So there's a specific way to actually find this. So if we do our first problem, amount is $2,500 times 1 plus, and the 2% is 0.02 over 4 compounded quarterly. That means 4 times a year. And then it's compounded 4 times a year for 3 years. So if you put that in the calculator, you'd be putting in 1 plus 0.005 to the 12th. All right. Compounded monthly is 12 times a year. So you'd have 1,500 times 1.004 to the 24th. And that's $16,508.22 after 2 years putting that in. So far we've looked at growth where you're making money. There's also a situation where you could be losing money, like if something depreciates. For example, if you buy a brand new car, the minute you drive away, your car is worth less money. So in this case, we would subtract the rate because we're multiplying by a number less than 1 because that's how you get things to decay, to go down, to become less. So the population of a town is decreasing. They were initially 1,700 people, and we want to know the population in 12 years because we're going from the year 2000 to the year 2012. 3% is written as 0.03, and since it's annual, we don't have the n value in this problem. So 1 minus 0.03 to the 12. So we have 1,700 times 0.97 to the 12th. Which is, so when you multiply something by 0.97, it goes down. There's another special decay situation, and that's called half-life. So if something has a half-life, that means that's how long it takes for it to cut in half. So we have cesium-137. This 137 is just attached to the cesium. This is not a number that we're using. So it has a half-life of 30 years. That means every 30 years it halves. So we start with 100 milligrams. So the amount is our initial amount times our constant multiple is a half, and it halves every 30 years. So if I want to know how many halves I have in 80 years, 30 times 6 is 180. So I would be putting a 6 up there. If you didn't know that, you could put the 180, how many years you want, over the half-life. That'll give you the 6. So we're just putting in the calculator 0.5 to the 6th times 100, and we will get 1.5625. That means it halves 6 times. Every 30 years it halves. And we've lasted 180 years with this cesium-137. All right, now we're going to talk about if something is linear, quadratic, or exponential. If you remember linear, y equals mx plus b. M is the constant increase, what you're adding each time, and b is the y-intercept. Ax squared plus bx plus c, that's our expanded form. We also have factored form of that. We have the quadratic formula we worked with, completing the square. And then exponential, where a is basically our starting amount, and b is our constant multiple to the x power up in the air. Okay. So if we look at the first situation, we have something that is decreasing by, looks like, pretty close to a constant amount. The first thing you have to look at is your x values. So our x values are increasing by 10. So if we do 144.5 minus 153, we get negative 8.5. And if we do 153 minus 161.5, we get negative 8.5. And if we do 161.5 minus 170, we get negative 8.5. So this is for sure linear. The slope is not negative 8.5 because that's every time this increases by 10. So the slope is actually negative 8.5 divided by 10, which is negative 0.85. And if we went back 2 spots to find our 0, we would just add 8.5 to go back 2 spots. So we'd have 178.5, and then that plus 8.5 is 187. So that's our beginning value. When x is 0, that's what we get for y. So that's our linear pattern. Our next one looks like it goes up and then back down. So this is probably quadratic. In quadratics, the second difference is constant. In lines, the first difference is constant. So are we going up by even increments? We are, so we can go ahead and analyze this. So 9.96 minus 12 is 2.04. 12 minus 12.76 is 0.76. And 12.76 minus 10.44 is 2.32. Now if we take our second difference, negative 2.04 minus negative 0.76, we get negative 1.28. And negative 0.76 minus 2.32 is 3.08. So our second difference is not exactly constant. That's because we have a problem. This is going up by 0.4, this is going up by 0.2, and this is going up by 0.2. So this is actually double the increment. So this should be cut in half here. And if we figure out what the increase is and figure out this middle number, it would be closer to a perfect quadratic because it's looking pretty quadratic. So if our second difference is in fact negative 1.28, that would mean that negative 0.76 minus what would give you negative 1.28. Like we could do a little problem. Negative 0.76 minus what would give you negative 1.28. So if you put that in your calculator, negative 1.28 plus 0.76, and then made it negative, this should be a difference. So I guess I'll do a different color. Of positive 0.52. So $12.76 minus 0.52 would give you 12.24. And then we'll see if that makes sense. 12.24 minus 10.44. So this difference would give you 1.8. So if we found the second difference now, negative 0.76 minus 0.52 is negative 1.28. And then 0.52 minus 1.8 is negative 1.28. If you remember, half the second difference is the A value. So right now we know that y would equal, it's an arc, so it's a negative, and half of 1.28 is negative 0.64. So we've got negative 0.64x squared, and then something else with our x and our c. We could find our c and go back 2 more and get that, and then solve for our unknown x with one of our points. Okay, that was a lot of information. Back to the exponentials. This looks like exponential decay. We're going down, so if we do 2 divided by 4, we get 1/2. 4 divided by 8 is 1/2. 8 divided by 16 is 1/2. So y equals starting amount, 32, because 0 would give us 32, times 1/2 to the x. So line, then quadratic, then exponential, the same way we studied them. And the last slide for today is identify what's going on for each of these. So the first situation looks like it's not linear. So do we think it might be exponential? It looks like it possibly has a constant since it's going down with these decimals. So let's start dividing. So 12.282 divided by 14,450 is 0.85. And 1,450 divided by 1,700 is 0.85. This is looking good. And 1,000 divided by 20,000 equals 0.85. So our exponential equation is y equals starting amount, 20,000 times 0.85 to the x, and that's exponential decay. All right, for our next one, let's go ahead and see if the first difference is the same. So we've got 11. Actually, let's go backwards. That's the best way to do it. So 68 minus 59 is 9. 59 minus 9 is 9. 50 minus 41 is 9. And 41 minus 32 is 9. So this is a line. So y equals 9x plus 32. All right, the next one is looking like it's probably exponential because it's increasing more and more and more. So let's test out. 80 divided by 40 is 2. 40 divided by 20 is 2. 20 divided by 10 is 2. So y equals starting amount times constant multiple to the x power. Okay, letter D. This is looking possibly linear. So 225 minus 275 is a decrease of 50. 275 minus 325 is a decrease of 50. 325 minus 375 is a decrease of 50. Now our slope is a decrease of 50 as x goes up by 10. So as x goes up by 1, it would be a decrease of 5. And that's just negative 50 divided by 10. So y would equal negative 5x plus 375. All right, ladybug population. A lot of these animals reproduce exponentially because they have litters of things. So I'm assuming this is again exponential. 270 divided by 90 is 3. 90 divided by 30 is 3. 30 divided by 10 is 3. So y equals starting amount times constant multiple to the x power. Okay, for the last problem, it looks as if it's probably quadratic because it's getting less and less, quicker and quicker. So let's go ahead and find our first difference. 64 minus 144 is negative 80. 144 minus 256 is negative 112. 256 minus 400 is negative 144. So if we look and see if our second difference is constant, negative 80 minus 112 is 32. Negative 112 minus 144 is 32. So I know that my second difference is constant, I know it's a quadratic, and my second difference is positive, so I know it's a smile. Typically, you can take half of the second difference to find your A value, but this time we're going up by 100, not 1, so that's not going to work. So let's go ahead and continue this pattern, because at some point pretty quickly here, we have to get to the peak, which is a minimum, because that's our parabolic curve. So 400, if our second difference is a constant of 32, then 32 less than negative 80 is going to be negative 48. So that would mean that 400 would be 16. And then if we do that again for our next one, because we're getting close here, 500, if we do 32 difference from the negative 48, that gives us negative 16. So negative 16 from 16 is 0. So that's probably going to be our peak, because 600, 32 difference from negative 16 is a positive 16. So 600 will get us back to 16. All right, remember vertex form. Y equals x minus h squared plus k. So this is our h, this is our k. So x minus 500 squared plus 0, I'm not going to bother putting it, equals that. I still don't know a. Should have put that in there. So I'm going to pick a number. So 256 and 100 to figure out what my a is. So 256 equals a times 400 squared. So if I divide that out, then a is going to be 0.0016. So my equation, and we can check this on a graph and calculator, and it does work, is 0.0016 times x minus 500 squared. Aren't you glad you learned vertex form? All right, and then